Let's analyze data further, finding the mean, median, range, quartiles, interquartile range, and outliers for the data below by using a line plot. So in this table, we have the high temperatures for Halloween for different years. So to create a line plot, we're going to write the numbers given below a line. So we've done that here. We have our line, and we're going to use the data from the chart to create the line plot by placing an X above the number each time it appears in the data set. So for example, we have the first number of 91, that temperature for the year 2003. So I would place an X over 91. I then have a temperature of 92 for the year of 2002, so I would place an X over 92. And I have another year or temperature of 92 for 2001, so I would place an X over the X I already drew for 92, and I would keep drawing X's until I've labeled all the temperatures given in the table. So here's the line plot that we've created with those different temperatures. So we can then use the line plot to find the measure of each variation. We can find the mean, the median, the range, the lower quartile, upper quartile, interquartile range, and outliers. So for these data points, for these high temperatures of Halloween, we have the mean. The mean, we still have to add up and find the sum of all the data points and divide by how many there are, which in this case is 740 divided by 8, which is 92.5. Then we have our range, which is our highest data value minus the lowest. It's the difference of the maximum and minimum. So that's 97 and 88, which is 9. In your line plot, it's really easy to see your maximum and minimums because it'll be your X all the way to the left and your X all the way to the right, those two numbers. So it's visually nice to see where your range is going to come from for that maximum and minimum. Then you have your median, which is your number in the middle. So in this case, it's 92. And then you have your upper and lower quartiles, which is the medians of the upper and lower halves of your data, which your lower quartile is going to be 90, and your upper quartile is 95.5. And then the interquartile range is their difference. So we're getting 5.5 from the 95.5 minus the 90. And then here you can see there are no outliers. Graphically with line plots, it's nice to see the outliers because usually you'll have an X on a number all by itself, either all the way to the left or all the way to the right, with a much bigger spread of numbers without X's. But here in this line plot, you can see that the X's are fairly spread out, so we can see that there's no outliers. Let's look at another example and do the same exact thing. Here, instead of temperatures on Halloween, though, we have the amount of calories in different candies. So first, again, we're going to make that line plot. So we've listed out all calories from 0 to 210 numbers to use, where we're then going to place an X above the number each time it appears in the data set. So we have that completed here. So we're going to use this line plot to then find each of the measures of variation, to find the mean, median, and range, the upper quartile, the lower quartile, and the interquartile range, and any outliers. So here we can see that we have a mean of adding up all of our numbers and dividing by how many there were. There were 11. So that's 1,500 divided by 11 gives us a mean of 136.36. The median is our middle number, which is 160. The range is going to be the maximum minus the minimum, or the difference of the maximum and minimum, which in this case is 210 minus 10, so that range is 200. We have our lower quartile. The median of your lower half of your data is 60, and the upper quartile, which is the median of your upper half of your data, which is 200. The interquartile range is the difference of the upper and lower quartiles. So we're getting 140 from 200 minus 60. And then here we have an outlier of 10. And you can see 10 is much farther away from the 60 and the 130, 140, 160, 200, and 210s. It's all the way over to the left, whereas most of the other X values are over towards the right, or to the at least to the right of 60. And again, that's visually because we've plotted this data on a line plot. So line plots can reveal your measures of variation and measures of center to help you really analyze and take a look deeper at the information given.